Even if you might learn something while we go over it, so play with me. So I think on page 113, looking at, let's start with number 6. Number 6 says, vector A is 3 units in length and points along the positive x-axis. So I'm just going to draw that. Something like that. So this is vector A, and it is 3 units in length. Says vector B is 4 units in length and points along the negative y-axis. See the and then it asks you to do a bunch of stuff with them, right? Okay? So when you add vectors, that's what we talked about last time we put it together, right? So to add the vectors, you can put them in. Yeah? So if we were going to do that, we can pick this one up. And I guess you can use this up to kind of see what's going on. You say, is that okay? Yeah. And then the resultant goes from where to where? Head. Yeah. Something like that? Is that okay? And that one should be pretty easy. 3 squared plus 4 squared is equal to 5 squared, so this is going to be 5. Okay? Now, when you do this, so we're talking about C. We can say that C, in this case, is 5 units in length. And we also need an angle. Any thoughts about where we might put that angle? Suggestions? Go ahead. Vector A and vector C, that's a good choice. This one right here. Okay? So you are always going to have your angle somewhere from where you started. So in this case, it makes good sense. If I had this on an axis, so if I'm going like this and like this, and I wanted to measure this other angle while it's the complement, that would be fine. I wouldn't get the same answer, right? I'd get 90 minus the answer that I'm going to get from this one. Either way is okay as long as you label it here. But let's go ahead and do it since we chose it already. How am I going to find the value of that angle? Tangent, right? Tangent, let's do it. So the tangent of that angle that I'm looking for is equal to, what is tangent equal to again? Opposite over adjacent. And again, if you don't remember that, it's you can look there. So which is the opposite one? 4 equals the adjacent? 3, so we do 4 over 3. But I want to know I need to know what theta is, so what do I actually need to do? Right. Theta is equal to 2 inverse of 4 over 3. Is that okay? Okay. So that's how you're going to approach each of these problems. It gets a little bit fun, though, when you get to B, right? For B, what's different than B? We're subtracting. So let's think about what that means literally. If we think about what something means literally, A minus B. Now you know how to add vectors, right? We can write this as an addition problem. We can say this is like A plus what? It's 2. What do you think that negative sign means? Perfect. It's in the opposite direction. So A is still going to go over that 3 units. And now instead of going down, where is this going to go? The negative go up. Okay? Now I do want to clarify, because I don't think we talked about this last time, the whole idea of north and south versus up and down versus whatever. answer should include north, southeastern. If the problem does not, then your answer should. So in this case, because the answer does not, when I find this angle, here theta, I'm just going to say above the x-axis, above the positive x-axis. In the other one, the angle would be below the positive x-axis. Does that make sense? Okay. We're just going to use some descriptive words there to explain it. In part C, something's different in C also, isn't it? What's weird in C? Right, there's like a D. A plus 2B. Now, we're just going to take that literally. We know what A looks like. And now instead of adding 1B, we're just going to add 2 of them. And just add. And which way did the original B go? Down. So we're going to go down. There's 1. But we need many of them. 2 of them. It's going to be something like that. And there's 1. Is that okay? Yeah. Like in the north, southeast, west stuff? I will, but not for this question because this question doesn't have north, southeast, west. Is that fair? But we're going to do a couple questions that do in just a second. Is that fair? Yeah. Does this kind of get you where you need to go on number 6? Okay. Can I go ahead and move on to number 8? Is that all right? What's that? From the x-axis. So in that one, what does it say? It says B minus A. So if we look at what that one's going to look like, it's going to go down first, and then which way is it going to go? Left. To the left, correct? So it's going to go over like this. And so the resultant is going to be something like that. So when they measure it, color here. You could measure it like from this axis, and then it would be the same complement angle to 4. From, you could say like negative from the negative y-axis, or you can measure it like this from the x-axis, or from the positive x-axis to the positive. Does that make sense? Does that answer your question? Yes? Okay. Does that make sense to everybody else? So there are lots of ways, lots of correct answers to that question, especially in terms of the angle. Okay? You just have to pick a correct answer. Also lots of question? A plus 2. Does that answer your question? Okay. All right, are we feeling a little better about that? Number 8. Oh, yes, number 8. Okay, so first answer, you don't need to use fractional techniques. I mean, if you did, awesome, but if you didn't, that's fine. Well, let's go ahead and see this one out. Okay. Number 8 is going to lead us to, actually, instead of doing number 8, I'm going to do an example problem. Can we do that first, okay? And then we'll do number 8. I think that this example problem will help. So, you may need to put your notes out because you don't want to probably have this in your homework section. I'm going to try this problem here. I think this will help answer the question. So this is back to Muppets problems, example number 4 from the list that we started last time. So Skeeter's total displacement is 15.5 meters at 31.7 degrees north of east. How far did he go north? How far did he go east? So this is like, if we think about this, let's draw ourselves a picture. So if this is our coordinate point. Let's break this stuff down. All the way. I want to draw 15.5 at 7 north. Go ahead. What's that? Good. Oh, first. On so many questions. Move the pencil 31 degrees north, about 31 degrees north. That's going to be here. Does that make sense? That's the direction that he went. Or she. Either is a girl. Excuse me. Is that okay with everybody? That's okay? Awesome. Now, why might we care? You know, when you're walking around your neighborhood or walking around a big city or something like that, you may start out at one place and end up at another place without having walked directly there. Does that make sense? So you might have to go over and then up, especially if you're walking around like a city on a grid system, right? Okay? So I want to know how far she went in this direction and how far she went in this direction. Can we do that? We can. We can figure that out. This one is 15.5 kilometers. Okay. How in the world would I figure out this part here? How would I do it? Use the sign. Make sense? Because this is the what side of that triangle. Use the sign. The approach is a little different. The sine of theta is equal to opposite over hypotenuse. So if I want to find, I'm going to do this A. The sine of 31.7 is equal to A over 15.5. Does that make sense to you? Is that okay with everybody? Are we doing all right? Do you need to use the inverse function this time? No. The only time you use the inverse function is actually looking for the angle. Okay? Go ahead and solve that for A. I want everybody to do it. Every single person, plug it in. I want to make sure that you know how to do it. So that you're not relying on somebody else to tell you how to plug that in. Once you've got an answer, check with your neighbor and make sure that they agree with you. Then probably generated. Go grab one. Once you've done oh, she.
I don't like that.
I know. Oh God. Oh, that's. They put what? Meters. They put 1 meters what? Look at the picture. Howard. With your roommates, I want you to call for the. I don't know, B. That sounds like a good choice. Work with your partners. Drop B. Come on, set it. Feeling is okay right there? Yeah. I'm gonna do it smiling. That's good. We're smiling. Go. What did we get for B?
13.
I haven't gotten that. Point. Okay. Like, no, that was just an example. What method in it?
So is Peter the one that's in Electric Mayhem, or am I thinking of something?
No, Peter doesn't actually do most of the stuff.
Yeah.
There's little Muppet, baby. Muppet has zero. I feel like it's my mission to be the Muppet ambassador to a new generation because so many of you don't know who they are. It breaks my heart. But like, Muppets are like such a cultural institution, and I feel like if I mix it up too much, then it'll get too complicated, right? Like, stay focused. Can you? What a beautiful thing. Yeah. Hey, hey. The game is that you put them all at the table, right? And then you draw the results in. This is crazy. Why? It feels sad, but yes. So we're going to start from the tail of the first and move to the head of the last. And then we're going to make a triangle that fits with this vector. So I'm thinking like one that looks like this. Does that make sense? Okay. So in order to find the resultant vector, I need to find how far up or how far north my dog went. Okay? And I need to figure out how far west that dog went. Everybody? In which vectors did the dog go north and south? The first one and the second. Right? The second one, he went some east and some north. So here, you need to break this into pieces, just like we did on the problem with Skeeter. It's a two-step process. Two-step process. We need to figure out how far east he went. That's going to be something like 8.2 times the cosine of 30. And we need to figure out how far north he went. That's going to be something like 8.2 times the sine of 30. Okay? So, what's up? I'm going to be combining this stuff. below the axis? Because actually because I told you 8.2 sine 30, and I found out that it was 4 something. And this is really, whoa. It was kind of an awkward spot. I really apologize. Hope that they'll fix it. So I found out this was like 4 something, so I know that it has to be bigger than 3 something. Does that make sense? If you don't know, then you can still kind of sketch it out. But it might stop down here, just know that your angle actually matches. Does that make sense? So are we doing okay? Okay. Do you want me to let you work on it a moment? Or do you have questions for me? Go ahead, Bridget, what's up? So he went 350 south, and then he went 8.2 meters at 30 degrees north of east, and then he went 15 meters directly west. Is that okay? So that's the original path. So let me make the original path. It's this one, and then this one, and then. But just like we did with Skeeter, remember when we broke Skeeter up into the X and Y stuff? We could break this path into down, and up, and over. That would be the result, right? The same place. So, if we know this down and we know this up, that tells us the difference. Does that make sense? Plug in 8 times the sine of 30. What do you get? 4.1. And if you do, so that was, what did you say, 4.1? So that's 4.1 north. That's after the dog from south. What is this? 0.6? So I'm going to do this a little bit. So right now this is 0.6. Okay? We're going to do another couple problems like this today. So if you're going like, oh my gosh, this is crazy, we're going to keep cruising on this, okay? So don't, yeah. North, because it's north of where we start.
The dog and
Mm-hmm.
how is that?
We started at going east and turn north. North of east. Does that make sense? The wording is funny, you have to get used to it. How long is this distance here? Can I figure that out? How would I figure that out? Yeah. Yep. Can I put a word to that? That would be the component. We haven't used that word, have we? Component that's going in the extra. So keep talking. Yes. Does that make sense? Wait. What's 8.2 cosine 30? 7.9 is 7.1. And 15 minus 7.1 is 7.9-ish? Yes? Right? And now I have a triangle. I'm going to write this on the board so you guys can see the triangle. Goes this way, goes this way. So instead of taking this really ridiculous route that the dog took, the dog could have just walked 7.9 meters west and 0.6 meters north, right? Or the dog could have walked that. How do I find this lane? Yeah, right there, right? So do it to figure out what that value is. Or it's like one of those questions.
Where'd you get the 0.6?
Where do we get the 0.6? Okay? Yeah. Keep asking questions. If I do something that seems crazy, whoa, what up? Just ask, please. All right, did you put that in your Yes. What did you get for a value? 7.1? Is everybody okay with that? Is that the answer then? Not quite. 7.9 something, right? Meters. We need an angle. We need that angle. Yeah. How are we going to find that angle? Let's do that. The tangent is equal to, again, tangent is which over which? So what number are you putting?
Point over.
Okay. So find theta? Did you get it? Four point three? So we'll say 4.3 degrees. But then we still need more, right? Oh my goodness, it's demanding so much of us. Yes, you can turn your facing west, you turn north of west. That make sense, everybody? North of west. Yes, ma'am. Perfect. Yep, as long as it's complement. Does that make sense, everybody? Yeah, that is a completely acceptable answer as well. 4.3 degrees north of west is what we got. Does that match with what you had? Okay. Okay. Yes, ma'am. Of course. Yes. So we just take it literally, right? North of west, we're starting off facing west. So here's what I do is I think about like, okay, from here, I start facing the west because that's one of the cardinal. And then, but I'm not going to go straight this way. I'm going to turn north from there. Is that okay? So that's okay. North of starting out. Right? Yeah? I've got two more problems like this for you to choose. Okay? I would like for you to work on them with you may work on them. You may work on them. If you're feeling like you kind of got this, you want to process. So I just ask is that if you get this stuff, awesome. Make sure your partner is feeling good. If you don't get it, advocate for yourself. Okay? Ask for help. I don't know where that comes from. And if you both stuff, come let me know. What do you put on there? I would like to work on number 1 and number 3. Okay? And let me be really clear because this is the first time we've really done this situation. Whenever I have a problem, it's always the ones in the brown box, not the second version. The ugly brown box. Make sense? Okay. So I'm going to let you start it. I'm going to you can take a look as you're going. Stop. Hold on. Hold on just a second. Let me just.